have been, I'm sure you have been, playing with triangles and quadrilaterals for a few years now, but hopefully we will see some sides of them which may have not been discussed. So let me start with a very basic question. How many types of triangles are there?
3 types, ma'am.
3 types.
Okay, and what are the 3 types?
Equilateral triangle, isosceles triangle.
Scalene triangle.
Okay, so okay, that is fine, but this is if you look from sidewise, right?
Ma'am, there are 2 ways of classifying triangles.
And what is the other way?
Ma'am, by angles, that is acute angle triangle, right angle triangle, and obtuse.
Okay, now have you considered what happens when you combine them? Like if you combine both sidewise and angle-wise, then total how many types of triangles can you get?
6.
Ma'am, 6.
And what will those be?
Right angle, acute angle.
No, I'm not just asking you to add all the 3 plus 3 and you get 6. No, that's not what I'm saying. You all have looked into geometry boxes, right? And there are 2 set square, 2 triangles in the geometry box, right?
Yes, ma'am.
Okay. Now, what is same in these 2 triangles?
Ma'am, both are 90 degree.
Both are right angle triangles. Okay. And what about what is different between these 2 triangles?
Ma'am,
One
one
is
is
45
isosceles
degrees
right angle.
and another is 60 degrees.
So one is isosceles and what is the other one?
Scalene.
Scalene. So see, within right angle, you get 2 types, right? You get scalene, you get isosceles. So now in case of obtuse angle triangles, can you get a right equilateral triangle?
No, ma'am.
No, ma'am.
Why?
The only possible values for the angles of an equilateral triangle are 60 degrees each.
And why is that?
Ma'am, because all the sides are
The
equal.
side of the
and hence
hypotenuse
the
is
angles have to be equal.
square of the another 2 sides, ma'am.
Okay, I can.
Excuse me.
Yes.
Ma'am, in right triangle, hypotenuse is the longest side.
Excuse me, please. Please raise your hands if you want to answer, because it can get a mess. It's a request.
Okay. Okay, Mridula.
Yes, ma'am. In an equilateral triangle, there are 3 sides, and all the 3 sides are equal, and hence the angles have to be equal. Angles between them have to be equal. And
Correct.
since some of the angles in a triangle is 180 degrees, 180 by 3 is 60 degrees each.
Right. But so we are talking about, that's correct. See, one thing that many of you were not saying is the angle sum aspect. Okay. That angle sum is 180 degree and therefore we cannot have more than 190 degree angles. Okay. And therefore we cannot have 3 right angles in a triangle. However, this angle sum property holds for triangles that are on a plane surface. Okay. The geometry which we do in school is on the plane surface. Okay. Where Euclid's 5th postulate holds. That is, if you have a line and you have a point outside that line, you can draw only one line parallel to the given line through that point. Okay. One and only one. Okay. But there are other kinds of geometry too. For example, can you imagine the globe, the earth? Okay. Now on an earth, it is possible to get a triangle which is an equilateral right triangle. Okay. Now what happens there is the straight lines on the globe are lines are basically the great circles. Okay. So these are the great circles whose center is the same as the center of the globe. Okay, so equator is a great circle. Equator is considered a straight line. Any two opposite longitudes, lines of longitudes will constitute a great circle. But other latitudes which are not equilateral will not be considered great circle because their center will be different from the globe's center. Okay, so now consider the equator. Okay, all the longitudes cut it at right angles. Okay, so consider the prime meridian. They obviously intersect at right angles. Now consider 90-degree east meridian. Okay, now that also cuts the equator at right angle. Okay, and 90-degree east and the prime meridian, they also intersect at right angle at the pole, North Pole, right? And at the South Pole. So here you have this triangle bounded by the prime meridian, 90-degree east and equator, and all three angles are right angles. Okay, so a right equilateral triangle is possible, but not on a plane. It's possible on the globe, on a spherical surface. Okay, now, so aside from that digression, so how many types of acute triangles are there and how many types of obtuse triangles are there? Let's start with the obtuse. How many types of obtuse triangles are there? Anybody?
Can it be infinite?
Okay. How?
Because like between 2 degrees, there can be 23.5 or something like that.
Okay, I'm not sure I got it. See, when we talked about right triangles, you saw clearly that you can have a right isosceles, okay, 90, 45, 45, or a right scalene. And the angle combination of right scalene can be anything. Okay, so basically two types of right triangles. We cannot have a right equilateral, as you guys argued, on the plane. So now the question is, how many types of obtuse triangles are there? Yes,
Ma'am, I
Rujana.
don't understand the word you're telling.
Okay, so maybe let me just start writing a bit. Okay, so let's say we have got all the triangles, okay, and so we know there are three types, okay. There is acute, there is right, and we have obtuse. Okay, now when we discuss the right triangles, we found two kinds of right triangles. Right isosceles, and we found right scalene. Okay, so my question is now, how many type of obtuse triangles are there? Like right triangle, we got two types. So if you think of obtuse triangles, how many types will be there?
Ma'am, 2.
Again,
Okay, and they will be?
Ma'am, scalene obtuse and isosceles obtuse.
Just like the right triangle, okay?
yes.
Yes.
Okay, so there is no surprise. Okay. And how about acute? How many types of acute triangles will be there?
Acute equilateral,
Three, ma'am.
acute
Okay,
isosceles.
so there will be 3 types. And here you can get equilateral. Okay.
Yeah.
So okay, now I'm going to claim that among these, okay, in one of these acute branches, there are actually 2 types, 2 subtypes. Can you guess which ones?
Ma'am, can you repeat it again?
Among these acute possibilities, there are 3 types, right? Equilateral, acute isosceles, acute scaling. Among one of them, there are actually 2 subtypes.
Scalene.
Okay, and what do you think will be the subtypes?
Ma'am, equilateral.
Come again?
Equilateral.
Okay, now all equilaterals are, kind of similar, right? So how can they be different?
Isosceles.
Actually isosceles. Okay, so let's consider all the triangles that, so consider triangles with integer sides, okay, whole number sides, and whose perimeter is 10 centimeter, 10 units. Okay, what are the triangles you can get? Isosceles triangles.
4, 4, and 2.
2, 4, 4. Okay, that's one possibility. Is there any other possibility?
4, 3, 3.
4, 3, 3. Yes. So we get 2 possibilities. One is 2, 4, 4. Another is 4, 3, 3. Okay. Or 3, 3, 4. Now, if you try to draw them, you will see how they are different. Okay. In 2, 4, 4, the equal sides are, which ones are longer? The equal sides or the unequal side?
Equal sides.
Right. And in 3, 3, 4?
Unequal side.
Exactly. So here you get 2 subtypes. Okay. So here you have longer equal sides and you have shorter equal sides. Now, can you say anything about the vertex angle, the angle between the equal sides for each of these types?
For the longer equal sides, it will be shorter between the 2 longer equal sides.
So if you have a triangle like this, like the 2, 4, 4, then what can you say about this angle?
Longer.
It
It will be the smallest.
It will be the smallest. What can be what is the highest possible value of this?
I can't write. 60.
Yes, it will actually be 60. Okay. I mean, it will not be exactly 60, but less than 60. 60 is the border, which if it touches 60, then what happens? If this angle becomes, then it becomes equilateral. And similarly for the other one, the 334 type, okay, what is the minimum value for this angle? Yes, Srinidhi.
Ma'am, can you please explain the two triangles again?
So in this case, we have two equal sides and they are longer. Okay. In this case, we have two equal sides, but they are shorter. Okay. And both are acute triangles. Okay. Now somebody said 180. Now this is an acute triangle. So can an angle be 180 more than 90? Is that possible?
No, ma'am.
Yeah. So the question is, see, for example, for this one, see, this can be as long and thin as you want, right? So obviously the minimum possible value is 0, anything positive, right? So the range for this angle is something between 0 and 60. Okay. So for this angle, it is between 0 and 60, and neither 0 nor 60 are included, because then if it is 0, then it becomes a line segment. It doesn't remain a triangle. Okay. And if it is 60, then it becomes an equilateral. Okay. Now,
Yes.
what about this one? The other one, the 334 type, where you have two shorter sides and one longer side.
Between 60 and 90, neither of them included.
Exactly. So this one, we get it to be 60 and 90 with neither included. Okay. And what is interesting is equilateral triangle is basically the border between these two. It's like separates the two. Okay. It's like the border. Similarly, so that makes equilateral kind of special. Similarly, can you figure out which other one acts as borders? There's one more triangle that acts as a border
Right
like this. Yes, and it's a border between which and which?
Right isosceles.
Right isosceles.
Yes, it is a border,
Short.
but it separates which two types of triangles?
Acute isosceles, shorter equal sides, and right isosceles.
Yes, it separates acute isosceles, more precisely, acute isosceles with shorter equal sides from obtuse isosceles. Okay. In a way, you can think of it like this, imagine a line joining these two. Okay. You can start with longer acute isosceles with longer equal sides. Then you get to an equilateral, then acute with shorter equal sides. Then you get to a right triangle, and then obtuse. Okay, so there are total, as you can see. Okay, let me pause and ask you one question. Do you think equilateral is a special type of isosceles?
With all the angles equal. All the
Yeah.
angles.
Yes, ma'am.
Okay, I'm glad you think so. Yeah, good. Because
ma'am.
actually it is. Okay. So there are actually 5 different. So the underlined and the circled ones, there are 5 different isosceles and 3 different scalene triangles. So total there are 8 types of triangles. Okay. Now, so, you know, it's not 3 and 3. When you combine them, it becomes 8 types. Okay. Now, here's a homework question which I want you to think about and then answer later. Are you familiar with dot sheets?
Yes,
So,
ma'am.
Yes, ma'am.
okay. And do you know that there are 2 types of dot sheets?
Yes, ma'am.
Okay. So now the question is, so let me write the question here. So question number 1 is, which of these 8 triangles can you draw on rectangular dot sheet? Okay. And similarly for question 2, which of these can you draw on isometric dot sheet? Okay. So if there is some triangle that you cannot draw on the rectangular dot sheet, then you need to think why is it not possible? Is it that it's impossible, or is it that you are not able to draw it? Okay. Similarly, is it possible to draw all 8 on the isometric dot sheet, or is it that something is not, it's just impossible? Okay. So if it is impossible, that needs to be proved, right? If it can be drawn, then you need to draw only one and that's it. Okay. So these are questions which I would like you to think, and then we can discuss them tomorrow. Okay.
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 Okay, ma'am.
Okay. Now let us consider quadrilaterals. Okay. Now, if you consider sidewise, I mean, we classify quadrilaterals, you know, etc., etc. But if you, in case of triangles, if we combine, we got like 8 types. Now, quadrilaterals are just like one side more than a triangle. So, if we consider quadrilaterals and let's say sidewise, then what are the different possibilities that we can get? Yes, Vaishnavi.
Basically, there are 3 major types.
Okay, and they will be?
Ma'am, parallelograms,
Okay.
trapezium, kites.
Okay. Okay. And how are you saying that these are the major ones? Are there quadrilaterals? So we are trying to consider a classification where you can basically put every quadrilateral in one bucket or the other, right? Now, I can probably show you a quadrilateral which may not fit any of these buckets. Can you see this quadrilateral? Is it
Yes,
a
ma'am.
parallelogram?
No,
No,
ma'am.
ma'am.
Okay, first of all, it's a quadrilateral, right?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yeah, it's not a parallelogram. Do you think it's a trapezium?
No, ma'am.
No, ma'am.
No.
Okay, is it a kite?
No, ma'am.
No.
Okay.
Yes, ma'am.
So if you consider these three types, then there are quadrilaterals which don't fall under any of them, right? So we need to maybe add to this. Okay.
Yes, ma'am.
Okay, so what will you add to this?
What is the question?
So the question is, what are the different types of quads if we consider sidewise classification? For example, you can consider
rectangle.
yes. So for example, you can consider all quadrilaterals which have all four sides equal. Okay, so that can be one type.
Square, rectangle,
Parallelogram.
rhombus.
Square, rhombus.
Okay, so the quadrilateral with all sides equal will be what?
Rhombus.
Square and rectangle.
Rhombus or square? Which one?
Ma'am, rhombus.
Square and rhombus both. Square, ma'am.
Okay. Now, would you say that square is a special type of rhombus?
Yes, ma'am.
Yes,
Yeah.
ma'am.
So we can say, so this type, we can actually call it 1-1-1-1, okay, because all of them are equal, okay, or okay, no, let's call this all equal, okay, and we know that this is basically a rhombus, okay. What else is possible?
Where the opposite sides are equal.
Okay, so we can have two pairs of equal sides. Okay, so
Equal side.
It bisects
two pairs of equal sides, and it is possible that the pairs are opposite. Okay.
Yes. As
Okay.
well as it is possible that they can be adjacent.
Exactly. So there are two branches that we get from here. Okay. That they are adjacent pairs are equal and okay, and opposite pairs equal, and we have adjacent pairs. Oops. And do you know the names of both these? So if you have opposite pairs equal, does it have a name?
Rectangle.
That's it.
Parallel.
Rectangle or parallelogram?
Parallelogram. Rectangle is a type
Parallelogram.
of parallelogram.
Yes.
Parallelogram.
Parallelograms are characterized by that. Okay, what about the quadrilateral whose adjacent pairs are equal?
Kites.
Ma'am,
Yes,
kites.
so those are kites.
Kites, ma'am.
Okay, okay, so we got that. Okay, now what else is possible?
Ma'am, all sides unequal.
Yes, that is very possible that you have four different sides, which is the case that I showed you. Okay, so four different sides. Okay, so all four are different.
On opposite side parallel.
Okay, and so you want one pair of sides equal?
Parallel.
Opposite sides parallel. Okay, we will come to that. But before that, Since
pair
we're
of
looking
sides
about
equal.
equal and unequal, what other possibilities are there?
One pair of sides are equal.
One pair of sides are equal and the other two are different, right? So we will have another here. Exactly one pair of sides, pair of equal sides. Okay. Now, in this case, this pair of equal sides, what are the possibilities?
Ma'am, adjacent, opposite.
Yes. So we can again have those two branches of adjacent and opposite. And but there are actually more possibilities. Okay. Now remember the two types of acute isosceles triangles where the unequal side was smaller or larger, longer, right? So similarly, how many possibilities are there for this? Any idea?
Ma'am, for opposite sides equal, we can have an isosceles trapezium.
Yes, we can. Thank you for that. And I was just going to show you that if you have opposite sides equal, you can make it an isosceles trapezium, but it need not be, right? It can be or need not be. And same thing, this is another one. Could you see the difference between these two?
Yes.
Yeah.
In isosceles trapezium, two sides are parallel.
Yes. Okay. We will come to isosceles trapezium. But did you see what I was trying to show you? Do you see the difference or the similarity between these? So here
Yes,
is
ma'am.
one, here is another, and here is the third one.
Ma'am,
Okay.
the length of the equal sides to the length of the unequal sides.
Yes. So in this case, the length of the equal sides are the longest. They are the longest sides. Okay. And in this case, they are the shortest. Right? And in this case, they are in between. Okay. So we get 3 branches from this. These are the 3 that I showed you. Okay. So that's equal equal sides longest, equal sides shortest, and equal sides medium. Okay. So these are the 3 possibilities. Okay. And I'm just going to make the branches and not detail it out. The same thing will work if the sides are adjacent. Okay, so here is a case where equal sides are adjacent and you have 2 other sides. Okay, the medium one and the small one. Okay, so I'm just going to make the branches, and I think you understand that. Okay. Right? Longest, medium, equal. Now, what else? Now, already look, we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At least 10 types we have got. In case of triangle, we had 3. Now we are already at 10 when we may not have exhausted everything. What other possibilities are there?
Parallel sides.
We'll come to parallel, but when you're talking about length, etc., have we exhausted every possibility? Is there other possibilities that are left? We have considered all equal. We have considered 2 pairs of equal sides. We have considered 1 pair of equal sides, and all 4 different. Is there anything we are missing?
3 equal.
Yes, 3 equal and 4th different. Okay. So that's another type that we need to include. 3 equal sides. Okay. Now, again, this is going to be very similar to the acute isosceles case. Do you think there are going to be sub branches of this?
The equal side's longer than the unequal side and the equal side shorter.
Yes, so equal sides longer and equal sides shorter. Okay. Okay, now we are almost done. The only other thing remaining is if you have 4 different sides, okay, you can combine them in different ways, right? For example, the longest sides, the 2 longer sides can be opposite or they can be adjacent. So I would ask you to figure out that in this case, okay, if you have 4 different sides, in how many ways can you combine the sides? Okay, well, how many possibilities are there? Okay, so that I want you to, think about and see how many types you get here. Okay, but otherwise we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I mean, there can be subclasses here, but see, we increased 1 side, okay? And the number of types increased so dramatically from 3 to, 12 plus, okay? Did you ever think of that? Okay, now, these are actually quite easy to deal with. Okay, now you see these models are very easy to make. Can you see what these are made of?
Straws.
Exactly, and all we have done is we have just stapled them. Okay, and we have stapled it in a way so that the stapler has 2 teeth, right? One of the tooth went through it, and that's why it can move like this. Okay, so what I would suggest, it's not a must, is if you can make these models, then you can explore and figure out a lot of things. Okay, so when I did it, then one thing that really came out became very interesting is, you see, I take any one of these models and I try to make it into a trapezium, okay? And here it looks like a trapezium, okay? That these two became parallel, okay? So once I try to make it a trapezium, it becomes kind of fixed. Otherwise, there are many possibilities, right? So the same thing works for anything else. So if I take this one, it's easy to make this trapezium. And if I shift it, then it's no longer a trapezium. If I take, for example, this one, then yeah, this way it becomes a trapezium quite nicely. Okay. So one question is that if you have, instead, if we had two pairs of opposite sides, okay, then we are getting so many parallelograms, right? There are so many possibilities. We are getting one rectangle and so many different parallelograms. Okay, but if we need to make only one side parallel, then how come we are getting a unique trapezium? Okay, we are getting a very unique trapezium, right? So why is this? Infinitely many parallelograms, but unique trapezium. Why is this? So this is a question. Okay, question number one. Question number 3. Okay, so maybe let me write it down. Given side combinations, why do we get unique trapezium but infinitely many parallelograms? I mean, this is a bit counterintuitive because you need more conditions to be a parallelogram. You need less condition for a trapezium. So what exactly is happening? So that's one question. The other question is, suppose you are given anything, right? See, for example, I can make this trapezium where the shortest side and one of the equal sides, they are parallel. But if I try to make the other two parallel, it's not really working. So if you have 4 sides given to you in order, okay, then which of the 2 sides will be the parallel lines, can be the parallel lines? So that's the second question. Okay, so think about this. We will discuss this tomorrow, but I would like to ideally for you to find out, given 4 sides of a trapezium, which pair of sides can be parallel? Okay, I mean, I don't know, maybe both sides can be parallel or just only one side will be parallel. So I want you to, figure that out. Okay.
Yeah.
And for that, it might help to make these if you can. It's not very hard to make. Or you can draw whatever means you want. You can try that. Okay. Okay. Now, See, first three things we already got. So they are rhombus, parallelogram, kite. Okay, so that is all done. Now, if we have three sides equal, then do you think it is possible to make them trapeziums?
Ma'am, please repeat the question.
If we have three sides equal, okay, then will it be possible to make them a trapezium?
No, ma'am.
Are you sure?
I think yes, ma'am.
Yeah,
Yes, ma'am. We cannot be able to make it.
you can make them trapeziums,
can, ma'am.
right?
Yes.
Yeah. And if you make them trapezium, then what kind of trapeziums do they become?
Isosceles trapezium.
Yes, yes. So that is done. So you can have parallel sides or not. Okay. Vaishnavi and Srinidhi, you have your hands raised. Do you want to ask something?
Ma'am, what are the three types of adjacent side equals?
Same. Equal sides longest, equal sides medium, or equal sides shortest. Okay. See?
They are same as opposite.
Yes, yes. Same, but they look different. So for example, here is the one with equal sides longest, where the equal sides are adjacent, and this is the case where equal sides are opposite. Equal and longest sides are opposite. Okay, so they do look different. Okay. Similarly, we have equal sides shortest, adjacent equal sides, and shortest opposite equal sides. Okay. And then there are the medium ones. Okay. Srinidhi, you have a question?
No, ma'am, I forgot to lower it.
Okay, no problem. Okay. Now, I want to ask you a couple of things. We have 10 minutes, or no, we have till 12:30, right?
We have 40 minutes.
Yeah, okay. So one thing is, you know what is an isosceles trapezium, right? So how do you define an isosceles trapezium?
Ma'am, when the non-parallel sides of a trapezium are equal, then then it is isosceles trapezium.
Okay, so you are saying that the equal sides of an isosceles trapezium cannot be parallel.
Ma'am, repeat it, ma'am.
So according to you, the equal sides of an isosceles trapezium should never be parallel.
Ma'am, it can't be, I think, ma'am. If it is parallel, then it will be a rectangle, no, ma'am.
Correct. Now, you know that rectangle is a special type of parallelogram. You know that.
Yes, ma'am.
Now, would you say that rectangle is a special type of isosceles trapezium?
No, ma'am.
Why not?
Ma'am, if in the isosceles trapezium, ma'am, it can't be a rectangle, ma'am, because the parallel sides will not be equal, ma'am.
Yeah, that I get. No, but you have a parallel sides, okay? And what if the other pair is also parallel and equal?
It will be the
Ma'am, then it
rectangle.
is a
Parallelogram, ma'am. Then it will become a parallelogram if the non-parallel sides are also parallel.
Right. Okay. But a more stronger case would be that is there any property of isosceles trapezium, okay, which a rectangle doesn't satisfy?
Ma'am, that all the angles 90 degree.
No. See, the question is there a property of isosceles trapezium which is not satisfied by rectangle?
Diagonals
Yes,
are not
ma'am.
equal.
Yes, ma'am. Angles are also not equal to 90, ma'am.
It can, but it can be. Nothing says that it cannot be.
Ma'am, but
Okay.
if it is 90 degree, then it will be a rectangle, no? Ma'am, it will not be trapezium.
Yeah, but if you allow, see, that's not a good enough argument to say that a rectangle cannot be an isosceles trapezium. Okay, first of all, any parallelogram is a trapezium. Do you agree or not?
Yes, ma'am.
Okay. So, since a rectangle is already a trapezium, what is exactly preventing it from being an isosceles trapezium?
Ma'am, other two sides are also equal and parallel, ma'am, in rectangle.
Yeah, but that doesn't violate anything about isosceles trapezium. Somebody said something about equal diagonals. What do you think are, how do you think the diagonals are for an isosceles
Ma'am,
trapezium?
diagonals do not bisect in isosceles trapezium.
Yeah, okay, they don't bisect. That doesn't mean in rectangle they can't bisect. In a parallelogram, okay, the diagonals are not necessarily equal, but in a rectangle they are. Is that a reason for saying that rectangle cannot be parallelogram?
Ma'am, diagonals do not bisect each other in trapezium.
Yeah, that's fine.
But it bisects in parallelogram.
See, yes, but we are not talking about parallelogram and trapezium. We are talking about rectangle being an isosceles trapezium. So rectangle can have, see, it's like this. What I'm asking is it possible that this is a larger set of isosceles trapezium? Okay, I'm going to write it IT for short, isosceles trapezium. And is it possible that within them there is a set which is the rectangles? Is it possible like this? Because if the outer one is parallelogram, then you agree that this is the case. All rectangles are parallelograms, but all parallelograms are not rectangles. But now I'm asking, is this possible? Is this true?
Yes.
Okay.
Ma'am.
Okay, so if you say no, then you have to give me something that is true for isosceles trapezium, but not true for rectangle. It's very, you will find a hard time finding such an example, such a property. The rectangle has all properties of an isosceles trapezium. The problem is how we define an isosceles trapezium. If we want to define it, saying that, see, two sides are equal, that we know. The moment we say isosceles trapezium, we all think of a shape like this. Okay, it can be fatter or whatever. We know that these two are equal and we know these two are parallel. Okay, this we know. Now, you need to specify that the other pair, there are one pair of parallel sides is there, the other pair needs to be equal. Okay, you need to specify that. But then this pair can, you need to keep it open that it can or cannot be parallel. Now, if you say that this one, this is the other, if you say that the non-parallel sides are equal, then you are ruling out rectangle, which is not good. We don't want that to happen. On the other hand, if you say, okay, so we have one pair of opposite sides which are parallel, and the other pair is equal, then you kind of leave it open that this may also be parallel and you end up getting a parallelogram. Again, that is not good. So there is a problem. The thing is, if you want to define isosceles trapezium properly, you cannot do it only with sides. What you need to do is you need to bring in the angles. Okay, you take if you take any parallel side, any one of the parallel sides, then the adjacent angles, the angles adjacent to that side, they have to be equal. That kind of guarantees an isosceles trapezium, and that allows, that doesn't, in case of parallelogram, opposite angles are equal. So isosceles trapezium doesn't become a parallelogram. It does in a special, very special case. And it does allow rectangle to be an isosceles trapezium. Okay. So, unfortunately, the way we have named it, isosceles automatically means iso equals celes sides. So we try to define it through equal sides, but there is a bit of a problem if we try to do that. Okay. So we have to resort to angle, and there is no other way. Okay. Okay. Oops. Okay. Now, no, Bhagya, I do not agree with you. See, rectangle is a special case of an isosceles trapezium. Okay. But not the other way. Okay. Okay, now back. Okay, so now I'd like to ask you something else. Yes, Vaishnavi.
Ma'am, I want to ask that we can say that all rectangles are isosceles trapezium.
Yes.
And we can say that.
Yes, we can say that.
Okay, ma'am.
Yeah. See, there are some very interesting things. For now, okay. Let me clear this. Okay. Let's see. So, I'm wondering if I should show you this. Okay. You see, we have got trapeziums, okay? No, hang on. There's one thing I wish I hadn't cleared it. Okay, okay. Now it's back. Let me remove these questions. Okay, because we were discussing which ones can be, can have parallel. So these, I'll just use a tick to show which ones can have parallel sides. Okay, so these two definitely can have parallel sides. So we have got this. Okay, these we have definitely checked. Okay, this is obviously has parallel sides. This has parallel sides. Now, if we have equal sides adjacent, okay, so yeah, so we did make it parallel, and here also we also did make it parallel. So these two we got. Okay, and in the case of medium one also, I believe it can be done. So looks like it can be done. Okay, so these are all good. Okay, now when we have a kite, can a kite have parallel sides?
No, ma'am.
Yes.
Okay, we have got both no and yes. So let's take a look at a kite. Okay, now if I try to make it parallel, you know, it kind of becomes flat. Okay, so can you give an argument why this cannot have parallel sides? I mean, you can force it to be parallel, but then it becomes something special.
Ma'am, the distance between two parallel sides is always equal, but in kite it's not possible to have both the sides equal, opposite sides equal.
For a given side combination, no. See, for in these cases, I mean, all of these, you know, given the side combinations, we made it, right? In this case, given a side combination, it is not possible to make it parallel, any two sides parallel. And the reason is that okay, I would like you to figure out the reason, because it may be connected to the question that I had mentioned earlier. Okay, so look into it, but right now what we can see is this one, it's not possible to get a kite. Now you also need to explore, when all four are different, is it possible to be, you know, make them parallel? In this case, it looks like it is possible. Okay, and you need to see what are the other things, and you know, so far it is, I'm going to put a small tick here. Okay, so the question you had with respect to parallel looks like, you know, yes, mostly it is possible to make them parallel, but given four sides, that is not guaranteed in most cases. In some cases, it is guaranteed, but not in most cases. Okay. Now, keep this picture in mind because I'm going to ask you a similar question. You see, when it came to triangles, we discussed both sidewise and angle-wise. Now, here we have just discussed sidewise and we have got 12 plus types. Okay, we haven't exhausted them here. What if we try to look at angles, all possible angles, then what happens? Okay, so if you can try to come up with a tree diagram like this for angles. So that's going to be fifth question. How many types of quads are there considering angle combinations? Okay, so I want you to consider, all four angles are equal, three angles equal, one different, like that. How many possibilities can you get? Okay, so definitely take a look at that. Okay, so that's another homework, because now I'm going to go and erase this. Okay. Okay. Yes, so what I was going to discuss is, this is a quadrilateral, right? Now, is this a quadrilateral?
Yes, ma'am.
Okay. Okay. Now, what about this?
Triangle.
Triangle.
Okay, so my question is, why is this not a quadrilateral?
Because three sides.
Three sides.
Okay, but why can't you consider these two as two different sides? I mean, here it was two sides, here it was two sides. Why not think of this as two sides?
And because of 180 degree.
Okay, so what? 180 degrees, so what?
Supplementary angle.
Well, I mean, in case of supplementary, doesn't two adjacent angles have to add up to be 180? Here we have only one. So yes, we do get an angle of 180 degree here, but why is that a bad thing, or why does it disqualify this from being a quadrilateral? Yes, Vaishnavi.
Ma'am, a quadrilateral is
line.
formed. Ma'am, a quadrilateral is formed by joining four non-collinear points.
Why? Why do you need them to be non-collinear?
Ma'am, because if points will be collinear, then they will lie in a straight line only.
So what is the big problem?
And can I say?
Yes, please.
Then in quadrilateral, there are four sides are required, and in triangle, there are three sides are required. When we make two lines, yes, two lines 180 degree, then it will be a line. Then it will transfer from four sides to three sides, and it is different from each other.
Okay, I see what you are trying to say, but I'm questioning the definition. Okay, basically what you guys are trying to say is, this is okay because this is allowed as a quadrilateral because this is not 180 degree. It's less than 180 degree.
Yes, ma'am.
This is allowed as a quadrilateral because this is more than 180 degree. No problem. You are not comfortable allowing this as a quadrilateral when this is a 180 degree. This is where the discomfort is. Right? Now, why are we uncomfortable allowing 180 degree as one of the angles?
Because we need 4 adjacent angles to construct a quadrilateral.
In this case, the 4 angles will form that. Okay, see, this is 180 degree. Okay, let's say these two are 50 degrees each. And this is then 80 degree. Okay. So altogether, you still get your angle sum. 50, 50, 100 plus 80, 180 plus this 180, 360. So no problem with the angle sum.
Ma'am, 4 vertices. 4 angles. And 4.
Well, we have 4 angles. Okay.
Need 4.
Ma'am, vertices.
Yeah, 4 vertices. One vertex is here. What is the problem if one vertex is here?
180 degree makes a line.
No. What is the problem if it happens?
But then 3 sides only be.
So the thing is, there is a problem. Your discomfort is perfectly fine. There is a problem, and the problem is kind of like this. Suppose we have this shape. Okay. And we allow a vertex here. Oops. Let's say we allow a vertex here and it becomes, so originally let's say it was A, B, C, and now it became A, B, D, C. Okay. So the same shape became a triangle and a quadrilateral. Okay. Now, if we can add one vertex here, we can definitely add another vertex here and call it ABEDC, right? And this way we can add infinitely many vertices, right? So what happens is becomes very difficult to distinguish between triangles and quadrilaterals and pentagons and hexagons and heptagons and everything, right? So you don't know what to think if somebody says pentagon to you. I mean, a pentagon can look like this, or a pentagon can look like, let's say, this with, let's say, A, B, C, D, and let's say another vertex here, E. Okay. Or a pentagon can look like this with A, B, C, D, and E. Right? So that becomes pretty complicated. Okay. Now, to avoid that complication, we do not allow 180 degree as an internal angle. And because we don't allow 180 degree, we need the vertices to be non-collinear. Okay. So that is why. Because sometimes if we allow some things, then it really makes our life very difficult and we don't want that. Okay. So this is why. Okay. It's the same reason why, for example, we don't allow curved lines as sides. Otherwise, okay, right now my drawings do look a bit curvy, but let's say, will you call this a triangle?
No, ma'am.
No, ma'am.
Right?
No, ma'am.
See, the problem is if you allow that to be a triangle, that means if you allow curved lines to be triangle, then this thing becomes a triangle. Okay. And a quadrilateral. And a pentagon and whatever you want it to be.
You can add infinite number of vertices.
Exactly, exactly. So, you know, a circle can become anything and everything.
Yes.
And that's problematic because you do want to classify the shapes and look into their properties and see, okay, this one has these properties, this one has that properties, and that's all of that. So if we don't figure out how to name them, how to categorize them in the beginning, then, you know, things can become quite messy. So that is why two things are not allowed. Curved lines are not allowed as sides. And second, for a polygon, the vertices have to be adjacent vertices. Any three adjacent vertices have to be non-collinear. You may be able to draw a figure something like this. Okay. In this case, these three vertices can be collinear, but they're not adjacent vertices. Okay. In this case, three adjacent vertices were becoming collinear. That was the problem, but not so in this case. This is allowed. I mean, you all realize that this is a very valid polygon, right? No complaint, nothing. Even though it has three collinear vertices, but they are not adjacent.
Yes, ma'am.
Yeah. So collinear vertices are allowed. Okay. But they cannot be adjacent ones. Okay. See, in mathematics, we have to be very careful of what we say and what we allow. Because one thing that mathematics helps us do is, you know, stretch our imagination and think of all possibilities. Okay. Like today you ironed out all possible quadrilaterals through sidewise. So then again, you have to see, okay, so can vertices never be collinear? What about this? Okay. So then how do you strengthen your definition? What is allowed? Yes, it can be collinear, but not if they're adjacent. Okay. You want to avoid this situation where, you know, from this or this, they become flat. So, okay. So words are very important to us and we need to be very careful with words. Okay. As long as you understand why they are, all is good. Okay. Okay. Now, once you have that, thing, there are things that you can play with. For example, if you consider the symmetries of quadrilaterals, you can think of which quadrilaterals have which kind of symmetries. Okay. And yes.
Square has both horizontal vertical symmetry.
So when you say vertical and horizontal, I'm assuming you mean that square has two line symmetries. Okay, so let's try to draw a square.
And three line symmetry, ma'am, one diagonal.
Only one diagonal?
Both the
Two
diagonals.
diagonals.
Yeah, so we have got this line of symmetry and this, and I have forgotten to switch, which is fine. And then we, oh, oops, the diagonal won't work this way. So we have got this diagonal. Shift it. Yeah. And we have got this one. So it has got 4 line symmetries, right? Does it have rotational symmetry?
Yes, ma'am.
Okay, so it has rotational symmetry too. So what I'm going to do is I'm going to make a box. Okay. So here I will mention whether they have line symmetry or not. Okay. So this means line symmetry is there and there is no line symmetry. And similarly on this side, it will be rotational symmetry. Okay. And whether it is there or not. So if it has rotational symmetry or it doesn't. So square, it seems, has all, right? Square seems to have both line symmetry and rotational symmetry. So square comes in here. Okay.
Triangle also has both line symmetry and rotational symmetry.
Yes, so rectangle also comes here. What else?
Equilateral triangle.
Okay, let's equilateral triangle also comes in. Yes, agreed.
What about rhombus, ma'am?
You tell me. Does it have both line symmetry and rotational symmetry?
Yes, ma'am.
Yes.
Then rhombus also comes in here.
Yes, ma'am. Line
Okay.
symmetry.
Okay. Now, can we think of something which has,
Circle, ma'am.
yes, circle also has both. Something which has line symmetry, but not rotational symmetry.
Parallelogram.
Parallelogram has line symmetry?
Yes, ma'am.
Are you sure?
No, ma'am, no.
No, ma'am.
Not all the parallelograms, ma'am.
Okay, parallelogram doesn't have line symmetry. Does it have rotational symmetry?
Ma'am, trapezium.
Wait. Let's finish parallelogram. Does parallelogram have rotational symmetry?
Oh, ma'am.
Yes, ma'am, it has rotational symmetry.
But it doesn't have line symmetry.
Yes, ma'am.
Okay, so parallelogram has no line symmetry but rotational symmetry, so it comes here. Okay.
Sorry to interrupt, ma'am. There are only 4 minutes for the session.
Yes, no problem. We are going to finish very quickly. Okay. Okay. How about something which has line symmetry but no rotational symmetry?
Isosceles trapezium.
Okay, yes, isosceles trapezium. I'm going to write it in short. What else? Anything else?
Kite.
Yes, kite. Okay. And can you think of a quadrilateral which has neither? It may not have a name.
Ma'am, scalene triangle.
Yes, scalene triangle falls in that category. Yes. What about isosceles triangle?
Has symmetry, ma'am. One line symmetry.
Yes, so isosceles is come here.
I'm a quadrilateral with all sides unequal.
Right. So there are quadrilaterals, okay, which has neither line symmetry nor rotational symmetry. A general trapezium will fall here. Okay.
Yes, ma'am.
Okay. So very interestingly, see, in case of triangles, you do not have a triangle which has rotational symmetry but not line symmetry. Okay. Parallelogram is the smallest polygon which has that property. Now, I want to leave you with this thought, okay, that if you flip this question, so right now you are basically looking at different types of quadrilaterals and trying to put them in these different boxes. But now if I ask you, so we had gone up to question 5, right? So I'll go into question 6 and 7, okay? If a quad has rotational symmetry, then it is, and you have to fill in this blank, okay? Similarly, if a quad has line symmetry, then it is, okay? So I want you to think about these two questions. Okay, so I think you have many questions to think about. Okay, can anybody remind us what was the first question?
Which of these 8 triangles can you draw on a rectangular dot sheet?
Yes, and the second one was which of these can be drawn on the isometric dot sheet?
Isometric dot sheet.
Yeah, okay. And question 3 was?
Given
In
a
how
side
many ways
combination,
can you
why can you make only a unique trapezium but infinite number of parallelograms?
Right. And fourth one was like, if you have 4 sides given in order, then which two can become parallel lines? Which 2 sides can become parallel? Okay, so finding the condition for it. Yes. And that is very linked to the fact, you will see the connection. We will look into the connection why, you know, a general kite cannot become parallel. What is going on? Okay, what happens if you try to make it parallel? Okay. Fifth was to figure out the angle-wise classification.
Yes.
Yeah. So these are to be 6th and 7th, not 7 and 8.
Yes, ma'am.
6 and 7. So we have got 7 questions for you to think about. Okay. And, you know, if you want, feel free to make this, because once you make it, you can explore many questions. For example, which ones are symmetric, which ones are not. Now, for trapezium, we got a unique trapezium, right? Yeah, so this way we got a trapezium. But if we want to make concave quadrilateral, this is one way. And I'm trying to see. In some cases, okay, so this is one way to get a concave trapezium, okay? The dark green and the blue are, they have the reflex angle. And okay, the other way is not possible. Let's try something else. Okay, so, okay, this is definitely possible. That also provided only one. I'm trying to see if there is anything that will allow 2 possibilities. Okay, this is one possibility. And see, this one has 2 possibilities. You can have a concave quadrilateral like this, or you can have it like this. So looks like some of them allow for 2 concave quadrilaterals, while some allow for only 1. So that is something which will be nice to explore. So this one definitely allows 2. Okay. And yeah, so this is something that can be explored. When are 2 allowed and when is 1? And something I have not explored yet. So these are possible if you have, it makes life easier if you have the straw models. Okay, so I'll end here. See you all next tomorrow.